Okay, so we decided to do a different problem than the one it was given on the paper. First thing you want to do is distribute. And then you're going to, well, you can't combine like terms, so you're going to move the variable and then solve your two-step. When you solve your two-step, you're going to get x equals -9/70, which is a fraction answer. We are going to leave it just like that. That's my recap. Okay. For this sake, we're not going to check. So this problem right here has one solution. And what does that mean? Does anybody have any idea what one solution means? One solution.
Only one answer.
Yeah, only one answer. What's the answer? Yeah, it's that fraction, -9/70. So one answer. And you're always going to have x. It might not be x. It could be a different variable, right? It could be a, b, c, d. X equals some number. And that number is your one answer. Okay? So an example of that, well, here's one example. Another example might be x equals 3 or a equals 5. That's what when you solve your equation, that's what it would look like. Variable equals a number. That means it has one answer, one solution. So if I were to take this fraction, and this is the part that we didn't do that I crossed out. If I were to take this fraction, -9/70, and plug it in where I see x, and then work the math out, it would work out. Okay, it's the one answer that will make that equation true. Questions about that? Okay, let's look at what infinite solutions looks like. So again, we're going to change the problem. Here's what I have for this problem. No, not +5, that's -5. Okay, first step, what's going to be our first step? Distribute, good. So we're going to take the -5 times the -8x. What do we get?
40x.
What is it? -5 times +1? And then I'm just copying down the rest after I distribute. Okay, next thing, combine like terms. Can I combine like terms? No. Do we notice anything?
They're the same thing.
They're the same thing on both sides. Okay, so that's going to be a big clue that this is infinite solutions.
That means that no matter what you put x.
So if we follow our next step, problem 3, we got to move the variable. Which one? Well, they're the same thing. So what would happen is we're going to subtract 40x on both sides. What is that? That becomes 0, right? This becomes 0. I'm left with -5 equals -5. Whenever you come up with your answer is a number equals a number, is that true, first of all? Is -5 equal to -5?
Yes.
Yeah, they're the same thing. That means it's infinite solutions. So, as Garrett was saying, infinite solutions means that any number will work for this problem. Any value of x. The first problem, the only value that x could be was this fraction. This problem, we could choose any x. Any x. So, for example, we're going to rewrite this problem right here on the check part. So, go ahead, we're going to write -5 parentheses, -8. Now, instead of x, what x do we want to use? We can choose any number we want.
1.
1, 2. Either one will work. Do you want to do 2, Alexa, and you do 1? Okay. Garrett, you do 1. I'm going to do 2 with Alexa, okay? So you can choose either one. If you want to plug in 2 or 1, that's fine. Plus 1 equals, I'm running out of room.
Is that the banner?
Yeah. 40. And here we're plugging in 2 because we want it to be 2 minus 5. Sorry. Running out of room there. Okay, first things first. What do we got to do first when we're solving problems? PEMDAS. Is it too hard to see when it's like that? What? Parentheses? Good. Parentheses. Inside my parentheses, what's -8 times 2? -16 plus 1? -15. So good. -15 is what is inside my parentheses here. What's 40 times 2? 80 minus 5. Good. We're going to keep going. 5 times -15, or -5 times -15. $75, and then 80 minus 5 is also 75. Notice that when we plug in 2, it works out.
I think I did it wrong. Yeah, I just did it wrong. Wait, no. That'd be -8, and then -8 is -7. You would pull this up as a spreadsheet.
Mm-hmm. Did it right. Yeah, you did it right. You just come up with the different, but it still works out. They both equal each other.
Oh, you still keep it in parentheses. Okay, I see what I do now.
Questions about this? So Garrett chose the number 1. We chose 2. It still works out. Any number that we plug in there will work. So what does infinite solutions means?
No matter what number you use.
Yeah, no matter what number you use. So any number will work. Your answer is all numbers, okay? So your answer, any number. You could write whatever you want here. Whatever will work. I was just trying something that would be easy to write. So answer is any number. What this will look like is a number equals a number. So when you solve your equation, we got -5 equals -5. So that's one example. What would another example be? 5 equals 5. What's another example? -2 equals -2. Is that what we said? -2 equals -2 might be an answer that we see. 10 equals 10. So if it's the number equals the number, that's infinite solutions. That means any number will work. Sometimes you'll see the answer is like written as an infinity sign, or it might say all real numbers. Both of those will work. Let's look at something. What if there is no solution? What will that look like? So go ahead, copy this problem down. Negative parentheses 2x plus 1. First thing we have to do is distribute, but what number are we going to distribute? What number is in front of the parentheses here? Not just any one.
-1.
A -1. Good. So go ahead and write that as a -1. So -1 times 2x. -2x. -1 times 1. -1. Can't combine like terms. We need to move the variable. Move the variable.